So let's try to do this one. How would we go about synthesizing this one? So first step, try to draw it. So pent implies how many? It implies 5. Huh? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Huh? Now that we have drawn the parent part, we know that at position 2, that's what the alcohol group is. So I could say 1, 2. Okay, let's put that there. Right, let's put that there. But then we also know that at the same time at position 3 there's an ethyl group. So 1, 2, 3. Okay, so let's put our ethyl group like that. Yeah. So now they want us to synthesize this. Whenever you are asked to synthesize anything with the same number, where the attachments are on the same position, you do exactly what I just said in the previous video and you get away with it, like it's easy. Whenever they give you attachments on different, whenever the attachments are on different loci, then there are a little bit of some problems there. However, the way I chose to work this one out, so again, if anyone has found, because you know these synthesis problems have so many solutions, right? Depending on the reagents you use and depending on the restrictions that the question will give you, right? So if anyone has found any clever methods, I would really like to see. So okay, this is how I approached synthesizing this one. So with this one, you can't necessarily cut the way we did that time. That won't really help much, because if I consider this the center and I start cutting from here, I will not really consider these groups. So one thing I could do is this. Yeah, so one thing I could do is this. You should know that there is an invisible hydrogen here that hasn't been shown. That's the first thing you need to know. So, okay, let me just add clarity as to why you can't just cut. So, like we've said, if this was the center, if I decided to cut like this, then I would have to be adding this entire group using our Grignard reagent. So that means the Grignard reagent would have to look like this. It would have to be like that, magnesium, bromine, like that. And then the Grignard reagent would have to look like this. Of which, to be honest with you, I've never seen such a Grignard reagent. I think if I was the one marking, of course I wouldn't mark this person wrong, the person who would use such a Grignard reagent. However, I think it's less practical. Anyway, it would depend on your instructor at the end of the day. But then, how did I go about working this one out? So the first way I went about working this one out is to remove this group here. So I started with a compound that looked like this. So I chose this part here, this portion. So you have something that will look like this. So where the OH is, you put a ketone group, and then you have that. You have something like that, right? And then here, where the methyl is, I take the methyl out and then leave a hydrogen. I start with that. So I've just taken the methyl out and replaced this with that. So if I started with this, a compound that looked like this, if I wanted to get this compound, all I would have to do is add a methyl group, and then I can add that methyl group by using a Grignard reagent that has a methyl group. So the story is the same. This will attack there. When it attacks there, you form something that will look like this, like that. You have your methyl group now. This is still a hydrogen. Yeah, so that is still a hydrogen. Story, same story. You use some hydronium ions, and then at the end of the day, you produce an alcohol with that. The question now we ask is this the same as that? Yes, it is, because the hydrogen is there in the methyl group. This is one possible way you could do it, right? And then, don't get me wrong, I'm not saying it's wrong to go this way, but I'm just saying it looks less practical. But if you're asked to list as many methods to synthesize as possible, please you can try whatever you can using the method I discussed in the previous video. Yeah, so that's pretty much it. The second method I'll use is one I came up with after doing a little bit of some critical thinking. Please take note, there are so many ways to do this. It only just matters whether you followed the instructions in the question. At the end of the day, there are so many ways to do this. So I was thinking and saying, what compound could I start with that is not branched, that at the end of the day I could get a branched compound? And so I realized that if I started with a compound like this, if I started with a compound that looked like this, right? If I put a double bond here, there is an interesting property of organolithium compounds that you'll be able to see will help us to synthesize the compound. But then now I decided to I decided to add a group here, but then I had to choose a group that is in such a way that this group should be able to be converted into an aldehyde, right? Should be able to be converted into a hydrogen, I mean. So what I did is I chose this group. So I chose an ester, sorry. So when I start with an ester like that, if I react an organolithium compound like that, right? There is a special property about organolithium compounds. Whenever your substrate, let me just call this a substrate, whenever your carbonyl compound has a double bond, an alkene group somewhere, the organolithium, before attacking this, it will attack the double bond, and then it will always attack at the least substituted carbon. So when you analyze this carbon and this carbon, which one is least substituted? Their degree of substitution is the same, therefore we can attack anywhere. So one thing you'll be able to see, this carbanion will attack there. When it attacks there, it will insert the group there, getting us a step closer to this structure. So it will look something like this. So say there, and then at this position here, this is where we've inserted our ethyl group, and then we have that there. We still have our ester group that side, like that. We still have our ester group that side. So what else can we do? So we're a step closer. We're supposed to get there, and then we're here. So what's the difference if we analyze? Okay, so I think the first, where are we supposed to get? We're supposed to get here, right? And then we're here. So what's the difference between the two? One, we're missing a hydrogen, and then we're also missing a methyl group. So we can do those things. So the first thing I could do is I need to add a hydrogen, right? Or change this into an aldehyde. Who remembers the reagent we use whenever you want to change an ester into an aldehyde? So the reagent we use is called Debau hydride, which is diisobutyl aluminum hydride. When you use this reagent, this structure will change from that form to this form, right? After I apply the Debau reagent, it will change from that form, from being an ester to being an aldehyde, right? Now that we are at the aldehyde level, let's compare. One thing you're seeing is the only thing missing is a methyl group. So we could add that methyl group with a Grignard reagent. So the Grignard reagent just has to have that there, right? And at the end of the day, we'll form something that will look like this. Same story. Same story. So this methyl group is this there, right? And then because the carbon is bonded to 5 things, one of the bonds has to break. Same story, exactly the same. Becomes negative, touches the, it ionically bonds to this. Same story, we add some wake up, or we add some hydronium ions. Before you know it, you have an alcohol. So you produce something that will look like this. Your hydrogen there and your methyl group. Are these the same? Yes, they are. So that's a possible method you could use to synthesize. But please take note, there are so many other ways. So if you have any genius ways that you've found, I would really like to see. Otherwise, that will mark the end of this video. I hope this video was helpful. And then make sure you comment down below if maybe I'm explaining too fast, or if you have a particular question you want me to answer. You can always contact me and then I'll be able to help you. Enjoy your day.